Uniform distribution is a type of distribution where all of the values have the same probability of occurring. Some standard types of distribution that you could see, or examples of this, would be when you are tossing a coin. The probability of landing on heads or tails has the same probability of a 50% chance. This could also be said when you are rolling a six-sided die. The probability of any individual side occurring is 1/6. Remember that when you're dealing with a probability distribution, all of your probabilities need to add up to be 1. To get a better visual understanding, we're going to look at the area of a rectangle. Remember that when you're dealing with a rectangle, you're looking for the base times height, where your base values are a given random variable x, and your height values are the probability of those individual values occurring. When you multiply your random variable times its probability across the entire set, you will have the value of 1, or the area equal to 1. Remember also that your probability values must also be between 0 and 1 inclusive. Remember that probability is also related to the area that you're working with. So when you're looking at the area of a rectangle, and we cut this rectangle in half, the value of each side gives us 50%. So the probability that we would go from one side to the middle is 50%, or the middle to the end is also 50%. We can further break down those zones into half again. So the probability of going from the beginning to one section is 25%. From one section to the middle is another 25%, and so on. We can then look at a problem and say that this value, or all values across this rectangle, are uniformly distributed. And then ask ourselves, for example, what is the probability of this middle section? We can do this for any section of our uniformly distributed area and relate the area to the probability of that event occurring. Let's look at a few problems on uniform distribution and how this will apply. During certain time periods at Heathrow Airport in England, passengers arriving at the security checkpoint have wait times that are uniformly distributed between 0 and 5 minutes. Find the probability that a randomly selected passenger has a wait time of at least 2 minutes. Our variable x along the horizontal axis represents our wait time in minutes, while the vertical axis represents our probability. The problem states that we are uniformly distributed between 0 and 5 minutes, giving us this rectangle. We are asked to find the probability that a passenger wait time has at least 2 minutes. Remember that probability relates to area when we're working with uniform distribution. So at least 2 minutes means between 2 and 5 minutes, and we're looking for the probability or the area of that section within this 0 to 5 minute time block. The formula for finding this value is actually pretty simple. We are looking for the value of the portion that is shaded out of the total. In this particular case, that's going to be the number of minutes possible, or the at least 2 minutes, out of the total number of minutes. The number of minutes possible, we need to find the difference between the 2-minute mark all the way up to the 5-minute mark, and divide that by the total number of minutes of the uniform distribution. Remember that the order of your subtraction matters. So the probability that a passenger will have a wait time of at least 2 minutes is 0.6000, or about 60% of this total wait time. Let's look at another example. A local brewery serves food as well as drinks. The wait time to be served is uniformly distributed between 3.15 and 8.75 minutes. Again, this can be represented by the horizontal axis for x. The section of wait time that is uniformly distributed is between 3.15 and 8.75 minutes. We are asked to find the probability that you will have a wait time between 5.13 and 7.87 minutes to be served. Again, visually, you are asked to find the portion of this shaded area out of the total that is uniformly distributed. In the numerator, again, we will have to find the difference between those wait times that we are asked to find the probability of. And in the denominator, we have the total values of the uniform distribution. This yields a probability of 0.4893. Again, thinking about how this relates to uniform distribution, that means that about 49% of the area shaded out of the total rectangle here we have that is uniformly distributed.